Okay, what's an example of a radical, Taylor? What's a radical? That's right. Like square root, that's a radical. Okay? But we don't stop there. This is grade 10. Okay, we can also do cubed roots. Is 8 a perfect cube? Is there a number multiplied by itself 3 times to give us 8? Yes, there is. That's what it means. What number is here? There's nothing here. Square root. There's a number multiplied by itself twice to give us 4. That's 2. Okay? These are all radicals. I can do the 11th root of I don't know what. Okay? I don't know what number multiplied by itself 11 times would be x, but it exists. Okay? Square roots. This is the one we're familiar with. All positive numbers have 2 square roots. One's a positive number and the other is a negative number. Remember, well, 4 times 4 is 16. Therefore, the square root of 16 is 4. But what's negative 4 times negative 4? It's also positive 16, isn't it? Okay? So can I say the square root of 16 is negative 4? Because there is some number multiplied by itself to give us 16. That could be 4 times 4, but it also could be negative 4 times negative 4. Okay? I just want you to be aware of this. This book, we have this in here. Honestly, I don't know why it says that. The author thought this is what we should do. And this is like professor level. But I'm going to say this. When we take the square root of 16, it could be plus 4. It could be negative 4. Because negative 4 times negative 4 is positive 16. Okay? So don't worry so much about this. I just want you to be aware. All right? You can say the square roots of 16 are 4 and negative 4. Okay, you got a couple options there. Cube roots. So this is the stuff that's new. Cube root. Okay? Now, excuse me. Bathroom. Yes? Absolutely. Nikita. Mr. Galloway, please. Cube root of a perfect cube is a nice number. Here's an example. Is there a number multiplied by itself 3 times to give us 1,000? Well, it's telling us what it is. 10 times 10 is 100 times 10 is 1,000. So the cubed root of 1,000 is 10. Okay? That's a rational number because this is a perfect cube. We can also, we can take the cube root of anything. Okay, that's fine. It's just not a perfect cube. It's going to give us a decimal. It's going to be irrational. Okay, we can still do it. Nothing wrong with that. Okay, here's the point we want to make. Is there a number multiplied by itself 3 times to give us negative 27? And again, remember your table of perfect cubes I pointed out last day? What times what is positive 27? 3 times 3 times 3. Well, what if it's negative? Negative times a negative is a positive. Times a negative is a negative. So that's fine. That works. Okay? You can't take the square root of a negative number because what times itself is going to be negative 16. If it's 4, it's positive 16. If it's negative 4, it's negative 16. There's no other option. We talked about this last day, right? As far as you're concerned, you can't do it. Then you get to university and they say, well, he was wrong. You can do it. Let's not worry about that, okay? Can't do it. We'll talk a bit more about that later. Okay? The cube root of a non-perfect cube is irrational. Always, always, always. Don't say, I know 7 times 7 is 49. That doesn't help you here. This is cubed root. Okay? Is there a number multiplied by itself 3 times to give us 49? It's a decimal. It's an irrational number. You can argue that there is, okay? But it's irrational. All right, so have we said this before? Yes, about 7 times. Let's make it 8. 4 times 4 is 16. Therefore, the square root of 16 is 4. Root 16 is 4. What number goes here if there's nothing there? 2. 2 roots of 16, that's 4. 5 times 5 times 5 is 125. So the cube root of 125 is 5. That's what it means. This is it in without words, the cubed root of 125. Okay, that's what that says. There is a number multiplied by itself 3 times to give us this. So I can take the cube root of it. That is a perfect cube, 125. 2 times 2 times 2 times 2, there's 4 of them. That's 16. So the fourth root, 4 of 16 is 2. How do we write that? Fourth root of 16 is 2. There's a number multiplied by itself 4 times to equal this. That number is 2, okay? And yes, we can do fifth root, so on and so on. 10 times 10 times 10 times 10 times 10 times 10 is 1,000,000. How many 10s do I have? 1, 2, 3, 4, 5, 6. So the sixth root, let me write it like that, of 1,000,000 is what? Yeah. Is there a number multiplied by itself 6 times to give us this? Yes, it's 10. Okay? What does mentally evaluate mean? Yeah, estimate, same thing. That means no calculator. Okay? Do yourself a favor. Don't use one where it says this. Where possible, keep that in mind. Always read the question, okay? Don't pull your hair out. If it doesn't work, better English. What times what, because that's a 2, is 49? Yes, most of us know this. Is there a number multiplied by itself 3 times? What times what times what is negative 64? Yes, but don't yell it out. Do we have a table for perfect cubes? Remember I said point it out yesterday? Put a little post-it there. You're going to want to refer to that thing for the next few days, okay? But how hard is it to make your own table? 2 times 2 times 2, 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64, okay? The cube root of 64 is 4. But this is negative. Does that work? Negative times a negative times a negative is a negative. That works, right? And for the first one, let's write it out. Tell me, does that equal negative 64? Yes, it does. 4 times 4 is 16 times 4 is 64. Negative. Okay, is there a number multiplied by itself 4 times to give us 10,000? Well, what's 10 times 10? 100 times 10? 1,000 times 10? 10,000, yeah. When you see all those zeros, you got to think. Remember, our number system's based on 10, right? You got to think 10. That's 100 times 100. Same thing. All right. Oh, boy. What do we do with this? Don't freak out, because half my grade 11s are still confused with this, okay? First time we've seen something like that. But what does fifth root mean? It means there's a number times by itself 5 times to give us 1 over 32. Huh. What could that number be? Well, you're on the right track. That is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. There's a number multiplied by itself 5 times to give us 32. That's 2. But that's not 1 over 32. But guess what a half times a half is? A quarter times a half is an eighth, times a half is a 16th, times a half is 1/32. Okay? So I know it's the first time you've seen that. That's kind of tricky. But, okay, just look at the bottom number. Think, what goes into 32? What do we multiply by itself 5 times to give me 32? And maybe we can piece it together. In about 10 minutes, we'll show you how to actually do this with a new rule, okay, for radicals. All right, 4. What times what times what times what will give me negative 16. If you see it, don't yell it out. Can that ever happen? Because it has to be the same number. If these are all positive, I don't care what it is, this answer is going to be positive. If these are all negative, because they all have to be the same, it's going to be positive. How could that ever be negative? The answer is it can't. Okay? So, again, we don't like these. They're giving you a question you can't do, but you need to know this. If you can remember this, I don't care what y is, but if x is positive, i.e. 2 square root, or 4, 4th root, 6th root, 8th root, 10th root, okay? You can't do that. Any even root of a negative number, and this year we're going to tell you you can't do it. Okay? Make sense? Hopefully. I know there's a lot of x's and y's here, but... And this guy, this is called a mixed radical. You remember what a mixed fraction was? That was like a fraction part with a whole number. This is a mixed radical, okay? We got a radical part and a whole number other than 1. So that's what we call a mixed radical. We'll get to that sometime in the future. What do you want to do? Visually, you want to just separate those. Let's just save the 2 till later. Think of, it's kind of like BEDMAS, but BEDMAS doesn't have radicals in it. But you want to do the radical part first. Is there a number multiplied by itself 3 times to give us 125? You got a table to refer to? If you haven't memorized it already, like Annika, what is it, Annika? 5. 5 times 5 times 5 is 125. So that's 2 times 5. Now bring the 2 down, okay? Do the multiplication of the 2, let's just call it, after you do the radical, okay? And 2 times 5, this is 10. If you were allowed a calculator, would you check that to see that this is the same as this? You should. So that's how you make sure you got the right answer. Okay, this I can't really tell you because everybody's calculator works differently, and some of you have figured out that your calculator doesn't work that well. Okay, like anything in life, you get what you pay for, right? If you buy no-name jeans, they might not be as cool as like a name jean, okay? I know they cost like 1/5 as much. Maybe the quality isn't as good, okay? With calculators, you definitely want a name brand, not, you know, Original Joe or Staples, okay? Get a Casio, get a Sharp, Okay, something good. All right, but they all work differently. So if you don't know how to do these, ask me after. It says use a calculator. Okay, you should know where the fifth root button is. And if you don't, like I say, ask me or someone else who has the same calculator. On mine, I go the fifth root, and on my calculator, I enter it the same way I say it, right? The fifth root of 1,024. That makes more sense than some of you guys' cheap calculators where it's backwards. You got to go 1,024 root fifth. Okay, that's like Chinese. It's backwards. That's 4. Again, what does it mean? 4 times 4 times 4 times 4 times 4, 5 times is that number. Did I know that? No. I don't have that one memorized. Okay? That's 4. This should be easy marks. If it says use your calculator, okay? Easy marks. It's like saying go on Facebook, message a friend. Should be an easy mark. All right? The seventh root of, seventh, fifth of negative 2187. Oh, can I take a radical of a negative? Can I take the seventh root of a negative number? Sure, as long as it's not even. 7 isn't even. If that was 6, don't even bother. Your calculator is going to say error. Maybe I should show you that. Okay, what's that? Negative 3. Who knew that? Not me. I promised you, I will do it. Okay, let's do the square root of negative 16. Error, non-real answer, okay, as promised. Can't do it, not this year. Okay, how good's your calculator? Does it do BEDMAS for you? Or do you have to do the radical part first, equal, then multiply it by 3, and you know your answer is going to be negative, so you know what? Why even worry about that negative? That's minus 3 times whatever this is, or do you guys want to fork out good money for a good one and just get 3 times the fourth root of 50,625? 45, but I didn't put the negative in there. This is negative 45. Okay? And we got this last day. A few of you asked me how to do that. And what was the answer? Brackets. If you don't put brackets there, okay, like in here, then you're going to get the wrong answer, because you know what your calculator is thinking you're doing? It's thinking you're doing that. And that's a completely different question than what this is, okay? If you put brackets there, then it says, okay, I want the cube root of the whole thing in there. All right? So, cube root of, this one already gives me a bracket, if you notice. 216 divided by 125, close the bracket. That's the cube root of the whole thing. 1.2. Hold that thought, because we're going to come back to that question. Okay? I'm not going to do all these, but read the question. To the nearest hundredth, that means we want decimal, tenths, hundredths, 2 digits after the decimal, okay? If you don't know how to do those, you're going to ask me. Radicals, yeah, that's what we've been doing. Some terminology. The whole thing's called the radical. The big number under the radical sign is called the radicand, okay? And the little guy, that's called the index. And I've said it about 6 times, let's say it again. If the index not written, we know it's what? Okay, square root. If there's nothing there, that means the index is a 2. Okay? This should be easy pickings. You got two choices. You got a 50-50 chance. Which one's the index, 5 or 75? 5. So that one must be 75. Okay? What's the index here if there's nothing there? Square root. That's a 2. We understand it's a 2, so we don't write it. Right? Okay? The index here, yeah, it's not 53, it's not 5, just the 3. The radicand, that's the number under the radical sign, negative a tenth. Well, what the heck is that 5? Well, yeah, it's multiplied by 5, just call it a coefficient. Right? Kind of like 5x. Variable's x, 5's the coefficient. Okay. Last day, that's yesterday's lesson. Assignment question number 10. Hope you all did it. Jeez, again. Not room again. Hey. Yeah, you back. Get back. Sarah. He's busy today. Okay. It asks you to do this question. You might have just thought it was just another question. It's actually quite important. I have grade 11s right now in pre-calculus asking me, is this true? Okay, so this is something you're going to want to try to retain. Okay? Not only for marks this year, but for next year too. Is this equal to that? Emily likes it. Is that pretty easy for us to prove? What's the square root of 9, Leon? 3 times, what's the square root of 4? Leon? 2. And that's 6, right? Is that equal to the square root of 9 times 4? 9 times 4 is 36. Is 6 equal to 6? Yuppers. Okay? That's a rule. We can do that. Let's highlight that rule. The product or quotient, you know that word quotient? Someone asked me that yesterday. The answer to an addition question is called a sum. The answer to a subtraction question is called a difference. The answer to a multiplication question is called a product. A quotient is the answer to a division question. Okay? So here, this is a product. We don't have quotient. There it is there. All right? So either or. So guess what? I'm kind of leading you to say this is going to be true too. The product of the roots of two numbers is equal to the root of the product quotient of the two numbers. Is that helpful in English? Not really. Okay? Math, you just need to know when you see that, you can do it. All right? Same thing if we're dividing. I'm going to write this a different way because I don't want to write divided by like that. Root 9 divided by root 4, that's the same as this, right? Okay. What is this? This is 3 over 2, right? Which is also known as 1.5. Don't believe me? Put it on your calculator. Is that the same as the square root of 9 over 4? Well, I already told you it's true, but you know what? Let's try to figure that out. The square root of 9 divided by 4 hopefully will be 3 over 2, otherwise known as 1.5, and it is. Okay? So this, I use the term split it up. Okay? If you get this, you can split it up. Make a radical on the top, make a radical on the bottom. Okay? From one radical to two radicals, split it up. If you get this, you can split that up into two separate radicals. Okay? I'm just saying you can do it. That's a rule. And that's going to help you solve some of the questions. All right, let's go back to this. I know that's 1.2. I've already done it. Let's split it up because I'm just learned that I can do that. That's the cubed root of 216 over the cubed root of 125. You have to use the same index. You guys know, first of all, the easy one, what times what times what is 125? 5. Well, this is bigger than 125. Anyone want to know what that is? Or do you want to check your table of cubed roots? What times what is 216? 6. Is that the same thing as 1.2? Aha. What do you know? Okay? So you actually don't need a calculator, hopefully, to do that question if you know this rule. Okay? You can split this guy up. That's a perfect cube. That's a perfect cube. This is the same as that. Okay? That's the meat and potatoes of this lesson. Now, this is not equal. I'm not going to highlight that because some of us are so visual, you'll try to memorize what's wrong instead of memorizing what's right. If it's add, you can't do that. Let's prove it. This is 3 plus 2, that's 5. Is that the same thing as root 13? Absolutely not. Okay? So this rule works if you multiply or divide. It does not work for adding or subtracting. Okay? All I can do is say it and prove it to you, but it's up to you to remember that. That's why we practice, practice, practice. Okay? So in general, my X is too big here. That's it. You like flags? Look at that, eh? Huh? Cool, eh? Sweet. I don't care what A and B are. If they're the same index, i.e., if they're both square root, we can join them into one radical. Same thing with dividing. We can join that as one radical. Okay? You can go vice versa and split it up, is the word I use in layman's terms. Okay? That's just something you're going to have to stick in your noodle. All right. How good's our memory? Is this true or false? Can I do that? Is that the same as this? Yes, it is. Only A is 3 and B is 6. A times B is 6 times 3, 18. That's true. Okay? That's our rule. We can do that. That's going to be our friend. Will help us get good marks. Can I do this? Well, I have the same index. I can join these. That's the square root of 20 over 10, which is 2 over 1, which is just 2. You bet. Looks good. Okay? Can I add them? No. Don't add or subtract. But you can multiply. Write this as a single radical in this form. That means x is one number. We have one radical. What's 8 times 3? Yeah, there we go. It's written as one radical. What's 7 times 3? I can do that, right? Root. One radical sign. 50 over 10 is also known as 5. So that's root 5. Okay? Those are all in this form. Uh-oh. Now what do I do? Who remembers? When you have a whole bunch of these, how do I want to do this? From the inside out. Okay? Do I know that? Yeah, that's 2. The rest, maybe I'm not helping with. Okay, so do I know this? Do you know the square root of 100? Yeah, that's 10. So I have this big one. This is just 10. Okay, over root 2. Now what can I do? It's the same index. I can join them in one radical sign. 10 over 2. How many times does 2 go into 10? That's root 5. Okay? A little confusing, but I hope you can see that. Now we're going the other way. I want this as a product of radicals. That's what it says, right? Multiply means product. What can I split 77 into? 7, 11. Get a Slurpee. Okay? 27. Can I split that up into two radicals? What goes into 27? 9 times 3. Can I split this guy up? Yeah. Actually, you got a couple choices, don't you? Root 4 times root 10. There's one option. What else goes into 40? Okay? It just says a product of radicals. Those are both right. There's no wrong here. Okay? You split it up into two radicals. It's opposite of what we did here. All right, that's it. 1, 3, 5, 6, and 8 to 13. And 43 minutes to get her done. This was lesson number 5. How many more do we have, guys? 2 is the right answer, not the many part. Okay, so that means this will be done, this whole unit chapter, by Friday. I have a review day before the test day, so we look for your test on Tuesday. Okay, first one. Tuesday, like this one.